Welcome back. So we are in week 7, and the second week in the physics portion of it, where we're talking about airplanes, Bernoulli's equation, concept of lift, and so forth. So let's continue on the theme. And what we're going to do, again, it's a reminder, we are the product we started out for physics was airplanes, and the concepts of the ideas is the Bernoulli's law, some fluid flow, and so forth. And then a little bit about the role the engineer plays in the development and the use of these products. Airplanes, looking fluid flow, and engineering. Okay, what we're going to do a little bit in this portion is this: how do we, how can we understand and use the lift equation? Okay, and then some calculations involving the lift equation. Okay. And if you go back to the last set of slides last week, you may have seen the lift force, the force that lifts an airplane or keeps it aloft, as it were, is given by this equation as 1/2 of a density, essentially weight per volume, velocity square, area term, and a something called CL, which is the lift coefficient. And if you remember in the last week, we noticed that the lift coefficient is dependent on the angle of attack, as it were. And it changes as angle of attack, and we'll talk a little bit about that. So for a plane to fly, for anything to fly in gravity, the lift has to equal to the weight. I mean, that it has to be like that, right? So for a plane to fly, the lift force that is generated must equal to the weight of the plane. Simple enough, right? So now we can certainly imagine when a plane takes off, it's going to have a lot more fuel and so forth. So over time, the weight of the plane is going to be going down. So you would imagine, therefore, that as the weight changes, the lift requirements will change. Simple, right? Okay, so what I'm going to go through now, and you'll see more of this in the PDF as part of the quiz that you'll be taking towards, we'll try to post it by Thursday or Friday of this week. This next week 7. Here are the following equations you'll need in order to do the lift calculations or velocity calculations using lift. One is calculation of what's called density. How do we calculate density? Using ideal gas law. The density is given by pressure times a value m, which is the, as you see in the equations, it means it has this very specific value for air, for example, at sea level. A gas constant R, it's called a universal gas constant, and T is the temperature in absolute scale, kelvins, Rankins, you've heard about. Okay, and we also need to know how does the pressure, atmospheric pressure, varies as a function of height. We know that on sea level, atmospheric pressure we call 1 atmosphere. How does it change as a function of height? And again, you'll see a lot of these details in the PDF. It may actually be very helpful for you to read that carefully. As given by this equation, which is, this is the pressure on the sea level. L actually is a term, which is a constant term. You'll see in the PDF. It tells us how does the temperature change as a function of height. For example, H is the height at which, say, a plane is flying. T0 is the temperature, is a reference temperature on the surface of the Earth, and there is a specific number for it. And it's raised to the power Gm divided by RL. As you said, m is a constant, G is the gravitational constant, R is the gas constant, and L again is the same L as here. So that's the second equation we need to know. And so some of these things are defined. M, as I mentioned, is a molar mass of dry air. R is the gas constant. T is the temperature, and so forth. And don't worry if this seems a little bit complicated. Actually, it's not. The PDF, I'll have a little bit more explanation. You can actually read and to figure out how to use it for some calculations we're going to do. Okay, the next thing you need to know is what is CL? CL is the lift coefficient. We don't have an equation for calculating CL, but it turns out that for the most part, CL changes as the angle of attack increases. And the slope of the line is approximately 0.11. So if you know the angle of attack multiplied by 0.11 gives you CL. But of course, one of the things to remember is that if the angle of attack is 0, CL is not 0, clearly because the airplane can keep on flying. So for the most part, what we're going to say, an angle is greater than 0, the CL is given by this equation. At an angle of attack of 0, CL is approximately 0.2, something like that. You can find lots of curves like that. Okay, so this is how you calculate CL. Now we know actually everything all of the terms are known, which allows to calculate what the lift experience an airplane is flying at a given altitude.